All right, this is 5-5, all about solving polynomial equations. Our goal is going to be we want to be able to solve polynomial equations by factoring. Okay, so remember the idea of factoring, right? We talk about this factor flow chart. Okay, so whenever you're given an expression, the first thing we want to check and see is, do we have a GCF, right? Do we have a greatest common factor that we can factor out? Okay, and then from there we want to ask ourselves, is it a binomial, a trinomial, or does it have 4 terms? Okay, and so this approach is still what we're going to follow, okay, but we're going to kind of add in a level here, okay, to see, does it have a degree of 3, or can it be thought of as something having a degree of 3, okay? So add in there, are there perfect cubes? Okay, and what we mean by perfect cubes are whenever we take a number and raise it to the third power. Okay, so 1 to the third power is 1, 2 to the third power is 8, 3 to the third power is 27, 4 to the third power is 64. Okay, so then these numbers are called perfect cubes. Okay, so whenever we take an integer and raise it to a third power, we get a perfect cube. So we have a special factoring technique that we can use whenever we have a binomial, okay, so whenever we have 2 terms with perfect cubes. So actually in our factor flow chart, this would really kind of fall under the binomial category, okay, if we have perfect cubes, okay. So if we have something raised to the third power plus something else that's raised to the third power, we can rewrite it in such a way as this, okay. If we're subtracting to begin with, okay, then this first quantity right here will be a subtraction sign, then a minus, and then a plus. Okay, so the way that we can remember these signs is if we start off with an adding sign, then if we start off with an adding sign here, then this sign here is going to be the same. Okay, so it's going to be the same as whatever we started with. The next sign that appears is going to be the opposite. Okay, so this was a plus, now this is going to be a minus, and then this final sign is going to be always positive. Okay, these are going to make the most sense when we go through examples. Okay, and then this is called the difference of cubes, and then the only difference is that the signs are flipped. Okay, so what I would like for you to know how to do is to first recognize that this is 2 perfect cubes. Okay, because we can recognize that x to the third power can be rewritten as x. Okay, and then 8 can be rewritten as 2 to the third power, right? Which then if we take the cube root of that, we get 2. Okay, so this is going to kind of be like our A, and this is going to be like our B in those formulas, right? You see that this is A to the third power. This is like B to the third power, which is 2 to the third power, and so now we can rewrite it as such. Okay, so if we have A to the third power minus B to the third power, we're going to take our first set of parentheses. We're just going to have each our A term and our B term here. Okay, x and 2. And then we're going to have the same sign in between. It's going to be a minus sign. All right, and then we're going to open up a bigger set of parentheses. Okay, so we've taken care of, let's see, we're working down with a difference, so we're working with this one, right? We've taken care of the A minus B, and so now we're going to square the A, multiply the A and the B together, and then square the B for these terms. So squaring our A term is going to become x squared. Squaring the B term is going to become 2 squared, which is 4. And then now let's multiply x times 2. And then for our signs, we want to have the same sign, the opposite sign, and then always positive. And that's that. Okay, so this is a factoring technique for taking something with a degree of 3 and factoring it. Okay. And so there's a little note down here. It says, remember our factor flow chart. You want to factor out the GCF first if needed, and that's going to come into play here. Okay, so looking at 16x to the fourth plus 54xy cubed, nothing is jumping out that it's factorable right now, okay? But our first step is to factor out a GCF, okay? So look at your 16, look at your 54, ask yourself what number can you factor out of both of those? We can factor out a 2, all right? We can also factor out an x. And then what we're going to be left with is 8x cubed plus 27y cubed. And now, this part that's in parentheses right here, we have a lot of perfect cubes, okay? So 8x cubed can be thought of as 2x in parentheses, raised to the third power. That's going to be our a term. All right, 27y cubed can be thought of as 3y in parentheses cubed. Remember your exponent rules. If we want to make sure that we're cubing the 2 and the 3, we have to put that in parentheses. All right, and that's going to be our b term. Okay. So now when we factor, this 2x is going to stay with us. Okay, but then we're also going to have that binomial and then that trinomial for our difference of, or excuse me, our sum of squares here. Okay, so we're dealing with the sum. We're working with the top one. We're going to cube we're just going to take our first term and our second term and write them regularly. So we have 2x and 3y. Okay, and then now we're going to square our a term. So 2x squared is going to give us 4x squared right here. Okay, and then if we square our b term, 3y squared is going to give us 9y squared. That's going to go right here. Okay, so you square it, square the first, square the second, and then in the middle you just multiply these two together. So 2x times 3y is going to give us 6xy. Notice how I left those spaces. I did that on purpose. Okay, so we can go back in now and fill out our signs. Okay, so we want the same sign. We started out with a plus sign. Same, opposite, always positive. Next thing we would want to check for is to see if this 4x squared minus 6xy plus 9y squared is factorable. So let's see if we can do anything with that. AC method. 4 times 9 would be 36. All right, we want to think about factors of 36 that would add up to give us -6 in the middle. Okay, 1, 36, 2, 18, 3, 12, 4, 5, 6, and 6. Oh, I also forgot, let's see, 4 and 9. 4 and 9, but as we're looking through these factor pairs, I don't know about you guys, but I'm not seeing anything that would add subtract to give us 6. So we're going to stop, okay? And we're done. You might be wondering, how would we have factored that 4x squared, xy, y squared situation? Well, we could have had an xy, a plus and a minus, or a minus and a minus, something like that. And that would give us the variables that we desired. Okay, but since we couldn't make the coefficients work out, we're done. Okay, so get through this next section and then I'll probably split the video up into 2 different ones. Solving polynomial equations. If a polynomial can be written as a product of linear and quadratic factors, so if we can factor a polynomial, then its zeros can be found. This is kind of recapping from our last section. Okay, we're going to set each of our factors equal to 0 and solve. All right, so let's find the zeros of this polynomial. So we're going to set this equal to 0, right, because the zeros are our x-intercepts. Whenever we're finding x-intercepts, we're going to set y equal to 0, or f of x, okay? So we're going to set this equal to 0 right here, and then we're going to try to factor. Okay, we have 4 terms. Let's try to factor by grouping. We can factor out an x squared here. Okay, and then we can factor out a -2. It's going to lead us to the following. Okay, 0 equals x plus 5 times x squared minus 2. Oops, changed colors on me. Okay, and now because we have this multiplication and we're equal to 0, we can set each factor equal to 0. Okay, we would want to check, since we have this degree 2, before we move on and set this equal to 0, we should check and make sure that this is not factorable. It's not, but that would be good practice, especially if it's trinomial. Okay, and now let's solve. x equals -5. This one, x squared equals 2, right? If we add that 2 to both sides. And then let's take the square root of both sides from here. Because we introduced the square root to the problem, we've created the potential for a positive or negative square root of 2, right? So our zeros are -5 and plus or minus square root of 2. That's it. Pause the video, give these a try. All right, hopefully when you took a look at this one, you factored out a greatest common factor of x squared first. You're left with x squared plus 5x plus 6. Okay, and then we can also factor this trinomial even further, right? X plus 5, x plus 1. And then from here, now we can set each of our factors equal to 0, okay? X squared equals 0, x plus 5 equals 0, x plus 1 equals 0, meaning that taking the square root of both sides, x equals 0. We don't have to worry about a plus or minus because 0 is neither positive nor negative. X equals -5 and x equals -1. Okay, with this one, 0 equals, let's factor out an x, the greatest common factor first. If you were tempted to try sum of squares here, the problem is that x cubed, that's a perfect square. 27 is a perfect square, but this x right here is to the first power. It's not a perfect square, okay? It's not going to give us a situation where we have a perfect square with an integer exponent, so we just got to factor out that greatest common factor of x. And then now we can set each piece equal to 0, okay? This x equals 0, x squared plus 27. Oops, I think my internet's having trouble here. Okay, x squared plus 27 equals 0. And then this one we're going to have to solve, okay, a little bit further. X squared, subtract 27 from both sides to get x squared equals -27. Take the square root, okay, because we are the ones introducing the square root into the problem, we've created the potential for a positive or negative. Square root of -27, and remember, oops, I kept my exponent here. And remember that we know how to handle these now, okay? We can work with imaginary numbers. So, from Unit 4, you should be able to recognize that this will become I times the square root of 27, which then we can simplify 27 as the square root of 9 times the square root of 3. And then that 9 would come out front as a 3, leaving us with plus or minus 3i times the square root of 3. And don't forget, we still have that 0 up there. All right, something that students get confused with a lot is how to know, like, when do you include x equals 0 as an option, okay? So if you have an x by itself, or an x squared that's by itself that's being multiplied, we need to include x equals 0, okay? Versus if we had a situation, see if I can find one. Well, I can't see when I'm in the notes, but say we had a situation where we had a polynomial 2 times x plus 1, x plus 4, okay? This thing out front doesn't have a variable with it, so we would not set that equal to 0, okay? We only set the expressions that have x's in them equal to 0. Okay. Pick up with the second half of this video in just a second.